Alright, we got quiz 4 study guide. And number 1, you've got different angles there. You've got 3 horizontal lines. You've got a kind of this tower thing over here. You've got a person. And you've got an airplane. And then you've got these different angles. One, 2, 3, 4, and 5. What is the description of angle 2 as it relates to the situation? This angle right here is what they're talking about. You just need to remember your definitions, okay? This is a angle formed by a horizontal and a line of sight. In this case, it's going up. So angle 2 is an angle of elevation. Number 4 down here is an angle of elevation. The rest of the angles in this picture are formed by a horizontal and a line of sight going down. My colors aren't very... oh, that's better. This angle 3 right here, that's a horizontal and a line going down. Alright, so 3 and 1 and 5, those are angles of depression. Angles 2 and angles 4 are angles of elevation. Alright, number 2. To approach a runway. A pilot of a small plane must begin a 9-degree descent. Elevation, yes, elevation. Number 2, to approach a runway, a pilot of a small plane must begin a 9-degree descent, starting from a height of 1,125 feet above the ground to the nearest tenth of a mile. How many miles? Be careful on this one, because this is in miles. How many miles from the runway is the airplane at the start of this approach? So they're saying this is the runway, and this is the plane. You're going to start this 9-degree descent, which is an angle of depression. You're looking for this, the length of the hypotenuse of this right triangle. So you're going to take this 9 degrees and you're going to write it here as well. And then in relation to this 9-degree angle, you're going to be working with opposite and hypotenuse. Opposite and hypotenuse is sine. So your setup is sine of 9 equals the opposite side, which is 1125, over the hypotenuse, which is the variable. So you multiply both sides by x. These will cancel. And then you divide both sides by sine of 9. Your sine 9s will cancel. So your x, or the length of this hypotenuse, is equal to 1125 divided by 9 sine, 7191.5. That is in feet. The question asked to the nearest tenth of a mile. So you need to take your feet and you got to divide it by 5,280, because that's how many feet are in a mile. And we get 1.4. So it's 1.4 miles from the runway at the beginning of its descent. Number 3 says that a highway makes an angle of 6 degrees with the horizontal. So looking at a side view, we've got a 6 degree horizontal, a 6 degree angle with the horizontal. So this horizontal line is the ground. Here's your 6 degree angle with the horizontal. This angle is maintained for a horizontal distance of 8 miles. Draw and label the diagram. To the nearest hundredth of a mile, how high does the highway rise in this 8-mile section? So we're looking for this right here. This is your highway making a 6 degree angle with the horizon, or the horizontal, over 8 miles. So we need to find this distance right here. To the nearest hundredth of a mile, how high does the highway rise in this 8-mile section? So we've got, in relation to the 6 degree angle, we've got opposite, and we are given the adjacent. Opposite and adjacent is tangent, so tan 6 equals the opposite side, which is what you're trying to find, over the adjacent side. So we're going to multiply both sides by 8, and 8 times 6 tan equals 0.8. So 0.8 equals this opposite side. So 0.8 miles. This says to the nearest hundredth, so if you just leave your calculator the way it is and push second fix 2, it will re-round it for you 2 places, so we got 0.84 miles. Alright, numbers 4 and 5. Number 4 says the sine of what angle equals 2 over 25. The sine of what angle equals 2 over 25. So this is a straight calculator problem. You take 2 divided by 25 in your calculator, you push equals, and then you push second sine, and that is 4.59. I said take 2 divided by 25, push equals. You'll have a number on your screen, then you push the second button, sine, equals. So for this next problem, you got cosine of what equals 7 over 14. It's the same process. In your calculator, you type 7 divided by 14 equals, you'll have a number on your screen, should be 0.5, and then the second button, the big green button, but now cos, and then equals. and that is 60. Everybody good with those calculator steps? Number 6. Conveyor belt carries supplies from a first floor to the second floor, which is 24 feet higher. So here's your first floor. Here's your conveyor belt. Here's your second floor. This is the first floor. This is the second floor. This distance right here is 24 feet higher. The belt makes a 60-degree angle with the ground. Here's your 60-degree angle. How far do the supplies travel from one end of the conveyor belt to the other? Round your answer to the nearest foot. This hypotenuse represents the conveyor belt. And you're trying to find out how far up the conveyor belt they're going to go. So we're trying to find the hypotenuse. In this case, we are dealing with opposite and hypotenuse. Opposite and hypotenuse is sine. So sine 60 equals the opposite side, which is 24, over the hypotenuse. So if we multiply both sides by h, h's on the right will cancel, and then we're going to divide both sides by sine 60. That will cancel the sine 60s. So the h is equal to, in your calculator, 24 divided by 60 sine equals. Alright, we're rounding to the nearest foot. So how far do the supplies travel from one end of the conveyor belt to the other? Round your answer to the nearest foot. So I got 27.7 in my calculator. 27.7 rounded to the nearest foot is 28 feet. So the supplies are going to travel 28 feet. Second part of the question, if the belt moves at 75 feet per minute, how long to the nearest tenth of a minute does it take the supplies to move to the second floor? Alright, so look, here's your proportion. If the belt moves at 75 feet per minute, the belt's moving 75 feet every 1 minute. And we got to make that equal to 28 feet in or over blank minutes. It's going to be less than a minute because it's only going 28 feet. So now we're going to crisscross multiply. So 75 m equals 28, and you can divide both sides by 75. Your minutes are equal to 28 divided by 75, which is 0.37 to the nearest tenth of a minute. So we got to go second, fix 1. So your minutes is 0.4. So the packages are going to travel 28 feet, and it's going to take 0.4 of a minute. Yes. Go. Has everybody got that written down? Alright, number 7. Find the value of x. Alright, these are a couple of inverse trig ratios. In relation to this angle that you're working with, the two sides are the adjacent side and the hypotenuse side. Adjacent and hypotenuse. Cosine. Okay. So, inverse of cosine of adjacent over hypotenuse will give you the measure of x. So in your calculator, that's 15 over 21, second cosine. And you should get a 44.4. That's going to be in degrees. Number 8 right below it. You're finding the measure of x again. In this case, in relation to this angle you're trying to find, you're working with the opposite and the hypotenuse. Opposite and hypotenuse is sine. You're trying to find an angle measure though, so you have to use inverse sine. So your x is equal to inverse sine of your opposite side over your hypotenuse. So again, that's 8 over 14, second sine, 34.8 degrees. Number 9, a right triangle has a hypotenuse length of 41 and one side length of 15. Do the side lengths form a Pythagorean triple? Alright, Pythagorean triple. Those are 3 non-zero whole numbers. A, B, and C, such that A squared plus B squared equals C squared. That's your definition of a Pythagorean triple. And what you're given in this problem is the A or the B and the C. And you got to find out if they're all going to be whole numbers so that A squared plus B squared equals C squared. So you take 15 squared plus B squared and you see if it's equal to, or you set it equal to, (41 squared). You end up subtracting 15 squared from both sides. So your B squared is equal to, in your calculator, this is a real shortcut. You can push 41 x squared button minus 15 x squared button and hit equals. And your B squared is going to equal 1456. And then you're going to take the square root of both sides to solve for B. So leave that number sitting on your calculator screen and just push the square root button. You get 38.2. Now, in this case, B has to be equal to 38.2 to satisfy this equation. Well, a Pythagorean theorem, or a Pythagorean triple, consists of 3 non-zero whole numbers. Do the side lengths form a Pythagorean triple? In this case, this is no. In order for this answer to be yes, this number, this third side, has to be a whole number. It's got to be a whole number. Number 10. What are you doing? What are you doing? Watching a movie? Jesus. I'm trying to do the study guide and you're busting out laughing because you're watching a movie in class. You need sine of A. Cosine of A. Put that away, please. Sine's opposite over hypotenuse. Here's angle A. The opposite side is 3. Hypotenuse is 5. Cosine of A. Cosine is adjacent over hypotenuse. Adjacent to A is the 4. Hypotenuse is still 5. Those are your two ratios. Number 11 is an 18. We're looking for the hypotenuse. We've got a 35-degree angle. This is a review from last week. In relation to this 35-degree angle, we've got the opposite side. We need the hypotenuse. Opposite and hypotenuse is sine. So your equation is going to be that the sine of 35 equals the opposite side over the hypotenuse. So again, it's times x, so that the x's cancel, is divided by sine 35. These cancel, and your x is equal to 18 divided by 35 sine, 31.4. Number 12. Forest ranger spots a fire from a 21-foot tower. So here's the ground. Here's his tower. It's 21 feet tall. There's a fire on the ground somewhere. Here it is. Here's a fire. He's looking at it. He sees a fire. The angle of depression from the tower to the fire is 12 degrees. Angle of depression is formed between a horizontal and a line of sight looking down. Here's your 12-degree angle. To the nearest foot, how far is the fire from the base of the tower? We're looking for this number right here. We're saying that the tower and the ground are perpendicular to each other, and they will intersect at 90 degrees. So we take this 12-degree measure and we move it to here because these are alternate interior angles. So what you've got is this 12-degree angle. You've got the opposite side of a triangle, which is 21 feet. You need the adjacent side of this right triangle. Opposite and adjacent, that's tangent. Tan 12 equals your opposite side, which is 21, over your adjacent side, which is, I'm just going to use the letter A. So again, you're multiplying both sides by A. The A's will cancel on the right. To get the A by itself, you divide by tan 12. The tan 12s will cancel, and your A will be equal to 21 divided by 12 tan. And I got 98.8. To the nearest foot, we're rounding this to the nearest foot, so we need a whole number, so that's 99 feet from the base of the tower. (13) is another straight calculator problem. You need inverse sine of 0.7. You need inverse cosine of 0.3. And you need inverse tan of 38.4. So that is 0.7 second sine, 44.4. Next, it's 0.3 second cosine, 72.5. And then it's 38.4 second tan, 88.5. And then these would all end up being degree measures. Alright, and then one more trig problem, number 14. You're solving for a side length. In relation to this 20-degree angle, you're working with opposite and adjacent. Hopefully you're thinking about tan. So we got tan 20 equals the opposite side over the adjacent side. Multiply both sides by the A. They will cancel. Divide both sides by tan 20. And your adjacent side will be equal to 9 divided by 20 tan, which is 24.7. And that concludes the study guide for quiz 4.